All right, so with this we're going to solve problems modeled by proportions. So when we have an application, we just want to be able to identify the quantities that are being compared and the ratios. So the first thing I like to do is just write a fraction of those quantities. So it says if 1 inch is a half a mile, how many miles are in 5 inches? So the 1 inch is talking about the map. So 1 inch on the map would be a half a mile in actual different distance. So the ratio is the quantities of the values in the map, which is in inches, over the quantities, the actual miles, right? And that's in miles. So now I'm going to use this, and what ratio is given? So what's the given ratio? Well, it says 1 inch is half a mile. So I know 1 inch on the map is the same as a half a mile in actual distance. And then I'm going to set that equal to the ratio that I want. So now in question it says how many miles are in 5 inches. So the numerator, they're talking about the 5 inches in the map, and they're wanting to know how many miles x would that be. So this is my proportion that I need to solve. So just setting up the proportion, making sure that the quantities are in the correct positions. So now going ahead and solving a couple of things. First, I do want to simplify this. So I'm going to multiply the top and bottom by 10 to move that decimal. So this would be the same as 10 over 5 equals 5 over x. And then I notice that 10 to 5, if I take and just compare equivalent fractions, 5 times 2 would give me 10, so that means 2 times x must give me 5. So I have that 2x has to equal 5. So finally, to solve, I'll just divide by 2, and I get x equals 5 over 2. Or if I divide that, this would be 2.5. So if x is 2.5, that means it'd be 2.5 miles, actual miles. So 5 inches on the map would give me 2.5 miles. All right, let's continue with the next example. It says an automobile mechanic recommends that 5 ounces of isopropyl alcohol be mixed with a tank full of gas, 16 gallons, to increase the octane of the gasoline for better performance. At this rate, how many gallons of gas can be treated with an 8-ounce bottle of alcohol? So for this one, again, the first thing I'm going to do is just look at the quantities that are being related. So it looks like 5 ounces of this isopropyl alcohol is being mixed with or compared to a tank of gas that's 16 gallons. So the first thing I'm going to do is just write the isopropyl alcohol is given to me in ounces, and I'm going to compare that to the gas tank, and that's in gallons. So the ratio that they give us is that 5 ounces of this isopropyl alcohol is being compared to the 16 gallons of gas in the tank. So that's what's known. And then I want to set that equal to what I want. And it asks me how many gallons of gas can be treated with 8 ounces, an 8-ounce bottle of alcohol. So the ratio that I'm looking for is if I have 8 ounces of isopropyl, so that's in the numerator, how many gallons X would be in the denominator here. So again, I want to solve this. Well, this one, the x is in the denominator, and 5 to 8 is not a good factor, not an integer factor between them. So I'm going to take the reciprocals of this. So I'm going to use reciprocals. And I'm just going to rewrite the reciprocals. This would be 16 over 5 equals x over 8. So to solve for x, we just need to cancel that factor of 8 in the denominator. So I'll just multiply both sides by 8. And the left side, 8 times 16 is 128. divided by 5 would equal x. So we could approximate this or change this to a decimal by dividing. We get x equaling 25.6. So with 8 ounces of isopropyl alcohol, we would have 25.6 gallons of gas. All right, the last problem, just bringing it down here, it says standard dose of an antibiotic is 4 cc's or cubic centimeters for every 25 pounds of body weight. At this rate, find the standard dose for a 140-pound woman. So again, we'll start by just writing the quantities. So we're talking about comparing the antibiotic, and that's in cc's, to the body weight, and that's in pounds. So what's given to us is that 4 cc's is compared to 25 pounds of body weight. And what we want to do is find the standard dose, find the antibiotic for a 140-pound woman. So we're going to have x in the numerator this time because that's the antibiotic, and divided by 140. So for this one, we want to solve by just multiplying both sides by 140 to cancel the 140. And the left side then becomes 560 over 25. That would equal x. And if we do that division, 560 divided by 25 is equal to 22.4. So the 22.4 would be 22.4 cc's of the antibiotic. So a 140-pound woman would need a dose of 22.4 cc's of the antibiotic.